Hello, in today's video I will be making a simple handheld gaming system using an Arduino Nano and an 8x8 matrix. Alright, so before we can start building our project, we'll first have to understand how our LED matrix actually functions. So I'm pretty sure we all know what an LED is. It's a light emitting diode where if we send a positive pulse to the positive connector of the LED and we connect the negative end to ground, we are able to get this LED to turn on and send out a quick pulse of light. But if we take a bunch of these LEDs and we connect them in a pattern that you see here, we are able to create something called an LED matrix. So what you see when we create this pattern is that we have two types of inputs and outputs. First we have rows and we have columns. So all of the rows that you see in this diagram connect to the positive end of all of our LED diodes. So we'll just label that with a plus, while all of the negative ends of our LEDs are connected to the columns. So what this allows us to do is that, say we want to turn on an individual LED in this diagram, say the LED that we see right here, all we have to do is send a positive pulse to its corresponding row and column to turn it on. So in this example, we send it in a positive pulse from R5 and connect C3 to ground, and bam, we just turned on that LED. And we can pretty much do this indefinitely until we are able to turn on the right LEDs to create an image. So say we also want to turn on the LED right here, all we have to do is connect C6 to ground, and bam, we have two LEDs turned on. But what you'll also realize is that, say we want to turn on the LED in this location right here, all we have to do is send current through R7 and connect C5 to ground. Bam, we got the LEDs on, but we accidentally at the same time, we would have accidentally turned on the LED right here and here, and this is not what we want. And the reason that those two LEDs turned on is because we already connected C6 and C3 to ground, and once we send in a current through R7, we accidentally turn on these two LEDs because these two LEDs are already turned on. So the way we would solve this issue is by, first we'll turn on these two LEDs and then we'll turn them off. And after we turn those two LEDs off, we will then quickly turn on our LED at C5 and R7. And we do this at high enough of a frame rate such as where the human eye perceives all three LEDs are turned on at the same time, even though in real life, or according to the perspective of the microcontroller, these three LEDs are actually flashing, where 1 second we'll have these two LEDs turned on, and the next second we'll have only this LED turned on. And that concept is simple enough. So as you may see here, the inputs just for this simple 8x8 matrix, we'll need about 16 digital pin inputs and outputs, digital pin inputs connected to our Arduino Nano, and that's essentially impossible, and it's going to be a pain to code. So in order to make this simpler for us to later program, what we're going to do is we're going to connect our LED matrix to an integrated circuit known as the MAX7219. And it's going to be, and this is the chip actually right here, connected to an 8x8 matrix. And this allows us to control this entire matrix only using 5 pins. 5 pins, and the reason because of that is because the MAX is controlled by the Arduino using a type of serial communication known as SPI, and I will most likely be going over this in another video, or you can Google that on your free time. And so yeah, so when we actually program our LED matrix, we're actually programming our MAX7219 microcontroller. We will be doing that by using the LED control library on the Arduino. Alright, now we're going to start wiring up our circuit. Right now we're going to start wiring up our circuit. The first thing you'll want to do is connect all all of your components to ground and the 5-volt rail respectively. And one important thing to remember is to connect your push buttons and your pacer buzzer to ground using a 200 ohm resistor respectively in order to prevent current from getting too high and possibly damaging those components. Okay, and once you're done doing that, you'll want to connect your digital input pin from your LED matrix to pin 12 on your Arduino. Then you will connect your CS pin from the matrix to pin 10 on the Arduino, and you will connect the clock pin from the matrix to pin 11. After that, you will connect your left push button to pin 4, your right push button to pin 5, and finally your pacer buzzer to pin 2 on your Arduino Nano. And congratulations, you're finished wiring up this project. So here's what my breadboard looked like after I was done prototyping my design. Alright, for the materials for the power supply, you will need one 18650 battery, a TP456 battery charger, and one 3.7 volt to 5 volt boost converter. Now I'll quickly go over how to assemble the circuit.
Now it's time for the final part of the project, which is our power supply assembly. We'll start this off by connecting the positive and negative terminals of our 18650 battery to the positive and negative input terminals of our TP4056. And once we have finished with that, we will then connect the output terminals from the TP456 to our TE110. And it's important to remember when you're doing this, it's best to add a switch into either the positive or negative wires from TE110 to TP456, because you cannot charge your battery while you are drawing current from it. And if you were to do that, you could possibly damage the circuit or possibly cause greater harm. And here's what the final assembly should look like. As you can tell here, while I was storing this circuit right here, I may have accidentally created a short circuit that may have created a fire. But we can just quickly ignore that, and you see here, our circuit works as predicted. We just flick the switch, we can power our Arduino, and we turn it off, and we can easily charge the battery up for the next time we need to use this to protect our safes or whatever. An important final note is that in the version of the TE110 I got, it did not have any output pins or terminals as we see on the TP456, so what I did is that on the back of the USB port, I connected a negative terminal and a positive terminal to it, and I connect these two wires to my Arduino in order to power our ultrasonic sensors and all that good stuff. You can just as easily connect the USB port to our TE110 and connect this end to our Arduino, but I found that a bit too bulky to find the little enclosure I made for it. And yeah, this is how we assemble as part of our project, and have fun.
Now that explanation I just gave may have been a bit quick, but you can find a more in-depth explanation in my last video going over how to make an ultrasonic car collision warning system. Alright, so this is what your final project should look like. You will have an 8x8 matrix, 2 buttons for left and right control, and in the back you see we have all the components exposed. Later I'll make a back casing for this somehow. For the power source, I have a 3.7 volt 18650 battery, a TP456 battery charger, and a 3.5 volt to 5 volt boost converter. And that converter connects to our Arduino Nano, which holds the code and does all the logic to run our game module. We then have a small piezo buzzer, 2 resistors and our buttons controlling this baby up, and we have our cables for our 8x8 matrix. And all you need to do to turn this on is just flick this small switch right here, and bam. And you are able to fully play a game of Snake. Every time you eat one of the apples, your little buzzer will make a sound, as so. And when you die, you have this nice little loading screen that pops up that tells you your score, and you're able to start a new game. Alright, I hope you guys like my video. Please feel free to subscribe or leave a comment in my comment section below, and have a great day.